Welcome to this video on steam locomotives in the Harz region, from the drainage pump to tourism, covering history, technology, and heritage. This video will explore the history, technology, and heritage of Harz steam locomotives, tracing their evolution from mine pumps to tourist attractions. A steam locomotive is a traction vehicle powered by water vapor, often generated by burning coal. This energy is converted into mechanical movement for the driving wheels, used for transporting people and goods on various railways. The first major technological challenge was flooded mines. The steam pump, invented by Thomas Newcomen in 1712, provided the solution. Steam acted on a piston to operate the pump, proving that mining and coal were the cradle of the steam age. James Watt, a key figure in steam engine development, introduced the centrifugal governor. This mechanical device automatically regulated the machine's speed, making steam use safer and more stable by adjusting the steam valve based on the rotation speed. George Stephenson, a steam railway pioneer, created the rocket in 1829 for the Rainhill trials, aiming to find the best steam locomotive for regular operation on the Liverpool-Manchester Railway. The rocket featured key technical innovations: a tubular boiler for a larger heating surface, steam blast in the chimney for better draft and combustion, and direct drive of the driving wheels, all of which became standards in later steam locomotives. The rocket achieved a maximum speed of about 45 to 50 kilometers per hour and had a mass of around 4.3 tons, using coal as fuel. These performance metrics were revolutionary for the 1820s. The rocket was the winner of the Rainhill trials and became a design model for steam railways. It proved that steam travel was safe, efficient, and profitable, marking the beginning of the modern railway transport era. Coal formed millions of years ago from plant debris under pressure and heat. It transforms from peat to lignite and then hard coal. Coal became the key fuel for steam engines and industry. From the 18th to 19th centuries, coal extraction evolved from manual labor in open and underground mines to using mechanical hammers, steam pumps for drainage, and the first mining railways for transport. This led to greater availability and reduced raw material cost. Coal processing involves sorting by quality and calorific value, drying, and sometimes preliminary coking to produce coke. High-quality coal with a high calorific value was essential for steam locomotives and industrial machinery. Lignite offers about 12 to 20 megajoules per kilogram, while hard coal provides around 24 to 30 megajoules per kilogram. Petroleum, with 42 to 46 megajoules per kilogram, has a higher calorific value, but coal was cheaper and more accessible in the 19th century. Major coal mining centers in the 19th century included the UK, Germany, the United States, France, and Belgium. These regions fueled the development of steam railways and the manufacturing industry. Coal was the ideal fuel for steam locomotives due to its high calorific value, generating powerful steam. It was also easy to transport and store, and widely available in Europe and America during the 19th century. Steam locomotives enabled fast transport of coal from mines to cities and factories. Dedicated coal transport rail lines were built, and local mining railways effectively connected mines with steelworks and ports. Steam locomotives accelerated industry and increased the availability of raw materials, serving as a stable energy source for factories and accelerating trade and urbanization. The link between coal and steam was the driving force of modern industry. Historical examples include Great Britain, with links between Lancashire and Manchester, Germany, with the Ruhr Basin and Rhenish industry, and Harz, where local locomotives transported coal to foundries and factories. Steam locomotives were catalysts for the economic transformations of the 19th century. The challenging terrain of the Harz region, with steep slopes, narrow valleys, and tight curves, presented difficulties for rail construction and adapting locomotives to the mountainous topography. The Harz Mountains required specific technical solutions, which included reinforced boilers and brakes on the steam locomotives. Special wheels or cogwheel systems were used for better traction on slopes. Technical adaptations ensured the safety and stability of transporting goods and passengers. This allowed steam locomotives to operate reliably in mountain conditions. The Harz Narrow Gauge Railway is a mountain narrow gauge railway network of over 140 kilometers, utilizing steam locomotives since the 19th century to the present day. The railway serves freight transport and tourist traffic. The Harz Narrow Gauge Railways are a living museum of the steam railway. Harz Narrow Gauge Railways are still the longest network of narrow gauge railways, and steam locomotives are used in the everyday operation of the railway. These railways play a significant role in the tourist attractiveness of the Harz region. The Brocken, the highest peak in the Harz, is the most frequently visited destination. Harz narrow-gauge railways maintain the historical railway heritage, offering tourists an unforgettable experience of steam travel and allowing them to see the preserved historical infrastructure.